A camera 500 feet away from the landing pad is filming the landing of a rocket. If the rocket descends at a rate of 50 feet per second, how fast is the camera angle decreasing when the rocket is 250 feet in the air? So we have the ground, and the camera is on the ground, and here's the landing pad, and the distance between them is 500 feet. And here's the rocket. It's descending vertically, and it's descending at a rate of 50 feet per second. And then we have this angle over here, which is the camera angle that is filming the landing of the rocket. So we have this right triangle. We'll use h for the height of the rocket and theta for the camera angle. Then we can see that the tangent of theta, tangent is the opposite over the adjacent, and this is h over 500. Where h and theta are functions of time, we know how fast h is changing. We want to know how fast theta is changing. So we are given that dh dt, the height is changing at a rate of 50 feet per second. And I left a little space here because h is decreasing. This rate should be considered negative to take that into account. And this angle is going to be decreasing, so we should conclude that d theta dt is also negative. And the problem is to find d theta dt at the moment that the height of the rocket is 250 feet. Okay, so we have a relationship between our variables, h and theta. So now we would like to find a relationship between their rates, and we do that by differentiating both sides of the equation with respect to t, and use implicit differentiation. The derivative of tangent theta, we have a composition here. The inside function is theta, because theta is a function of t, and the outside function is the tangent. So this derivative is secant squared, that's the derivative of the outside, evaluated at the inside, theta, times the derivative of the inside, which is d theta dt. On the right side, it's a little bit simpler. We have 1 over 500 times h, so the derivative of that is 1 over 500 times the derivative of h with respect to t. That's the constant multiple rule. Now the secant is 1 over the cosine, so secant squared theta is the same as 1 over cosine squared theta. So if I multiply both sides of this equation by cosine squared theta, then we get d theta dt is equal to cosine squared theta over 500 times dh dt. On the right side, I'll just put the cosine squared on top of the fraction, and here cosine squared times sine squared cancels. Cosine squared times sine squared is 1. So this means then that d theta dt at the moment when h is 250 feet is equal to cosine squared of theta at that moment divided by 500 times negative 50 feet per second. this 500 here is in feet, and the cosine of an angle has no unit associated with it because the cosine is the adjacent divided by the hypotenuse, and they're both in feet. So when you divide the adjacent by the hypotenuse, the feet will cancel out, so the cosine's not going to have any unit. Now we're trying to figure out the cosine of theta at the moment when h is 250 feet. So we use the Pythagorean theorem to find the hypotenuse. The hypotenuse will be the square root of 500 squared plus 250 squared. So that's our hypotenuse. And that will simplify. We can factor out the 250 squared. So if we take the 250 out of the square root, if we take the 250 squared out of the square root, that gives us 250 times the square root of. If we factor out 250 squared here, we are left with, since 500 is 2 times 250, we'll be left with 2 squared plus 1 squared, if you will, and that's 5. So our hypotenuse is 250 times the square root of 5. So let's get back to our calculation then. We have 1 over 500, and then the cosine of our angle theta is the adjacent, which is 500, divided by the hypotenuse, which is 250 times the square root of 5, and we have cosine squared, and then times negative 50. So 500 squared will cancel with 500, leaving 500. And then we have 250 squared times 5, because we're squaring the bottom, so that's going to square the 250 and square the square root of 5. And then we have times negative 50. We can cancel things here. The 250, one of the 250s completely cancels out and makes the 500 into a 2. And then we'll cancel the 50 with the 250, leaving a 5. And I think that's everything. On the top we have a negative and a 2. And on the bottom we have 5 times 5. And our unit is just per second, because our units here, we had feet per second, and then we're dividing by feet. So feet cancel. And we have the dimensionless unit to measure our angle, the radian. So I'll just fill in the word radians there. So the angle has to be decreased at a rate of 2/25 of a radian per second. The minus just means we're going to decrease the angle. So how fast is the camera angle decreasing? It's decreasing at a rate of 2/25 of a radian per second at the moment that the rocket is 250 feet in the air.